Okay, here I am a couple of George Jones cassette tapes later, and I have got it, well, hopefully fixed. We're going to find out here momentarily. This is a wide shot. You could see here what has happened since the last time you were here. My original intent was to just take some bus wire and go across. How many of us know what that sound is all about? How many of you checked yours? My intent was to take the bus wire and just bridge across the traces, and I started doing that okay, and then not so okay, because then the traces started getting even worse, and so I had to run these longer jumpers to satisfy the multiple breaks in here. I thought it would have been a lot easier than trying to take the bus wire and tack on here. And with the distance between these traces, I was also afraid of the bus wire slopping over and maybe touching traces and shorting these out. Let me go ahead and bump you in closer so you could see. And here's a tighter shot, so you can now use, well, whatever you want to use. Cleaned it up. It looks a lot worse on camera than it does in person. But here you could see the multiple breaks in the trace here and whatnot. Now, I've gone through and I've checked for shirts and made sure that my new jumpers are getting proper continuity, and they are. And then to check for shirts between the jumpers, well, some of them I was getting continuity shirts on. I keep saying shirts, you know why? Because my voltometer, the continuity meter on it, it says SHRTS. Looks like shirts. So that's why I keep calling it shirts instead of shorts. Anyway, so I've got that all put in place. A couple of these were checking for shorts without a schematic and without knowing beforehand what I was supposed to get. I don't know if we're going to blow this thing up or if it's going to magically work. We're going to find that out here momentarily, because I have not tested it. I've just finished it and brought you back. So, since I done this kind of work here, my original thought was come back in with some new solder mask and lay it back down on top of the board and make it all nice and pretty. But that's no longer going to happen. We're just going to leave it open air as is and wish it the bestest fondue. I cleaned the board, cleaned up the flux, and I just went in and cleaned the entire board in general. And so we're at the testing point. Now, in order for me to do this properly, to run these jumpers this high up here, the face, the head, was actually covering this section, and it was not going to happen. So I went ahead and removed it, and in doing so, had these pins right here. Not sure if you could see it, but you could see it down here. That went into these headers right here. Not a problem. However, pulling this cover off, I did find, or how is it? I spied with my little blind eye. I don't know why I said blonde. I got two capacitors right here. They are bulbous. So if this is successful and we can move forward with the project, I plan on going through and recapping this device. I do have one capacitor here on the face, and that's all I could see, and I'm pretty confident that's all there is to it. Now, the casualty list underneath here was very minimal, thankfully. I thought it was going to be a lot with all those cores and everything. I replaced this capacitor here, although it checked good. It was right here underneath the wires, and I thought, well, if I'm going to end up replacing capacitors, if this is successful, I might as well do that one now and not come back and fuss with these wires or have to remove them. So I went ahead and removed it. That one actually tested good. And this one's a 25 volt at 2200 microfarads. And this is a Nippon Chemicon. And I do believe the capacitors in here are good brand. I don't remember. We'll find out here together as I go through these. The other one that I pulled out, which checked out really bad, is this 1000 microfarad at 16 volt. And the name brand on this is CESS Japan. That one checked bad. The next one is a Rubicon, and that is a 470 microfarad at 25 volts. And I do believe this is the one that spilt its guts. However, you would not know that because it is super duper clean. But it too checked really, really bad in the picofarads. So these two were in this area, and it was one of these that caused the problems. However, like I said, the bottoms look absolutely fine, as you could see. I see nowhere that it leaked. If it wasn't these, I'm not sure what else it could be, because those were the only two in this area where the traces were. I see no other drainage leakage coming from any other area, and as you can see, this is the destruction field. So let me do this. Let me go ahead and put these together, and we'll fire this up, and we'll see how successful I was. Now, the one thing I did forget to do was to bring my power plug back. Let's see, is this where I wanted to do? I'm filming this actually a couple days, well, more like about a week and a half later. Had another project I ended up doing in the middle of this, and so this got set aside. I'm sure we all know how that is. Alright, so this is going to take me a few moments to fiddle. Instead of watching me fiddle with that, let me break out the fiddle and we'll fiddle with the fiddler. Let me put this together. I'll be right back. Okay, I've got the head coupled back in via those headers. I got to tell you, those were a little challenging to put together. The wires just kind of bend on you a little bit. But I got it after a few minutes. Alright, so outside of that, the face is just flapping in the breeze here. It's not bolted down. But I'm thinking that it should be grounded. If not, then we'll ground it. I've got my cables. Got them plugged into the power supply. Now, the plan of attack is I'm going to go ahead and couple this up to the power supply. And we'll turn this on, and then we'll slowly bring up the power supply until we get to 12 volts. That way we don't have a big inrush of current. We can kind of control it a little bit. Like I said, I'm not sure if those wires are supposed to be connected somewhere along the way. Okay, power supply is now connected. I know you can't see it, but it's set to 0 volts. Let's go ahead and turn this on. What should happen is we should get a display. I'm not sure if any of the idiot lights are going to come on, I don't think there's a power light. I think it's just a display. I know you can't see the power supply, so I'll bellow out what we're doing. Okay, so now we're going to turn it up. We're at 1 volt, 2, 3, 4, 6, 7, 8, 9. Oh, I heard noise. 10, 11. Look at that. We've got lights. Yes. And 12. That is awesome. Let me kill my direct overhead light so we can see it better. How awesome is that? Let me get you in just a little tighter. All right. So that's awesome. We got no squelch. And power switch seemed a little dirty. These do have goofy power switches in them. All right, so we have nothing. So let me grab a jumper, and then we'll hook up a ground to the case and the face. Let's see if that's a communications issue. And don't look like it. All right, well, we're one step closer to something. Remember those 2 capacitors in the CPU section of the board? I wonder if that could be something. So very cool. Very cool. You know, I'm at 12.7. Let me bump it up to like 13.8. Oh, 12.9. So let me look at my current. How much current did I allow? Okay, so right now it's drawn 0.84. Let me see if I can turn it up any. Yes, there we go. Hey, there we go. There's my problem. Not enough current. That is awesome. And my voltage is at 16. Let me turn that down. Okay, so that's 13 volts, don't like. What's the current? Current's at 0.85, so let me increase the voltage. It's almost, I smell something. Let me kill the power on this real quick. Let me check the back to see what it's supposed to take. .8 watts, or 13.8 volts. So I definitely have enough. confirm. Well, that's only saying, hold on. Oh, guess I should plug the power supply in so I might get a right reading. Yeah, I'm getting my current, my voltage out at 14 volts, and I'm drawing 1 amp. Now it's working, and I'm 16.9 volts. Yeah, 16.9. Let me bring this in so you could see. And I'm pulling 0.86 amps, so I've got it throttled down there, but it's working. And I got the meter all tingled up. Okay. It's working. Let's see here. So this is our default frequency. So let me go 129.545, enter. And there we go. However, I have no squelch. So, I think what I'll do is I'll fire up the generator and we'll put a tone to see if we are indeed getting a signal, but it's working. That's awesome. Give me a moment to get the generator set up and I'll come back. Alright, I got the signal generator turned on and plugged into the rear. Let's go ahead and fire this back up. One thing I noticed real quick is the voltage regulator is getting pretty hot. Where it's positioned up underneath the fuse here, it's really hard to see what number it is. I'm having a hard time seeing it, so I'm going to try pulling it and see if I can find out what the input and the output is supposed to be, and measure it and go from there. I don't want to just say exclusively it's bad caps that's causing issues, but we do know that I do have 2 bad ones over here, and since I've already had 2 bad ones in the area of the power supply section, who knows what else could be bad or has gone bad that I just may have missed. So anything is plausible. I will, of course, check values in the power supply section and see what's happening. I may also entertain plugging in the AC cord and see if I get a different result as well. Let me turn the power supply up because I have voltage going to that. So at about 16.2 on the power supply, and it's drawing at the moment 0.91 amps. So we see we have a frequency, and it looks like it might have remembered my frequency. No, it did not. Didn't think so, because I don't think, well, I can't tell. There may or may not be a, yeah, there is a 9-volt battery in here for backup. Came with it. I guess I should pull it and just to get rid of it. I don't know if it's good or not. So let's go ahead and program a frequency in here just to confirm that yes, it's still working. Let's go with 124 dot 565. Enter. Oops. Okay, now what's going on? There we go. 1, 2, 4 dot 5, 6, 5. Enter, and it took us to the closest thing, 124.575. And let's go ahead and punch that into the signal generator. 124.575 megahertz. We have volume all the way up, still no squelch noise. Turn the gain up on the generator. Oh, need to give it some audio. And we're going to give it a 400 hertz tone, because that's so much better than 1,000. And let's turn the gain up on the generator. I have 1 volt. 1 volt going into it, and we're not hearing a thing. All right, to confirm that we are getting a signal from the generator, I'm going to use this BDST signal analyzer. I'm sorry, signal tracer. And give me just a moment to get this connected. For those that are not familiar with a signal tracer, just think of it as a very sensitive amplified speaker. And so I connect the ground wire to chassis. I have the probe. Let's go ahead and turn this on. You hear the noise. And so when I touch the tip of the probe from the generator, I should get a beep. And I'm not. Alright, so touching the antenna probe, I did not get a tone. However, touching a resistor not that far from there, I did get a very faint tone coming through. Alright. So as you can hear, we are getting tone into the radio. We're just not coming out of the... Oh. Yeah, I got the speaker still connected. For a moment there, I thought I had disconnected it, but it's still there. Oh, I also forgot to mention that what else I replaced out of here was 3 jumpers, and that's it. 3 capacitors and 3 jumpers. I feel I lucked out. Alright, so here I'm touching a transistor, and I am getting tone. So, it works. It has great promise. So I think my next step is attack the power supply. Find out what's happening with the power supply, get it stable, get it fat and happy. And to replace those 2 capacitors on that one board that's bulbous, I'm going to have to remove that whole board, and it's going to be an involved thing. So if I'm going to do that to replace 2, I'm just going to replace them all. I will probably kind of sort of do a shotgun approach effect. I mean, the power supply, I've only got 3 more capacitors in that section. The rest of the board appears that I may have 6 more capacitors on it. I'll go through, I'll check all the values, have a lot of carbon resistors in here. Check everything out best I can, and we'll go from there. I guess hook up an external speaker. Let me see if I could do that real quick. If I could couple a speaker to this. Actually, why don't I just go through the... It does have a external speaker jack, so let me try that. And nothing. I have a amplified speaker, so we would definitely be hearing noise. And we do scan. Okay, so we're going to check the squelch out. So we have the squelch all the way up. I think the squelch is backwards, and so if I bring it down, that should allow that to scan. There we go. So the squelch works. It's the audio that we have nothing happening. So I need to find out where the audio section is and check that out. There are some IC chips in here. Don't know what they go to. But we'll go from there. That's all I can do. All right. I'll come back when I have some further progress.